Hello students, in previous class this problem is pending. Now see that total 2n boys are there. We want to divide two groups, each group containing n boys, but two tallest boys are in different groups. That is the problem. Out of 2n persons can be selected n persons in two groups. This is the first group, this is second group. Total chances is n of s. N of e, whatever is there, two tallest persons out of 2n persons, remove them. Remaining 2n minus 2 persons are there. Now the two tallest persons are in different group. First group T1, second group T2, or first group T2 or second group T1. These two people we can arrange later, no problem. First, out of 2n minus 2 students, one group is n minus 1. Second group is n minus 1. Now, these two persons can be arranged in two ways. Two ways. How? This is first way, T1, T2. This is second way, T2, T1. Now calculate this. 2n minus 2 C n minus 1. That is 2n minus 2 factorial divided by, apply the NCR formula. We get what, students, in denominator? N minus 1 factorial into n minus 1 factorial. N minus 1 C n minus 1, that is 1 into 2. Now, required probability P of E, that is equal to n of E by n of S. First I am writing n of E, 2n minus 2 factorial divided by n minus 1 factorial into n minus 1 factorial into 2. This is n of E. Now observe the n of S. This is n of S. Numerator 2n factorial is there. I am going to try decreasing. 2n into 2n minus 1 into 2n minus 2. I am writing up to 2n minus 2 only because numerator is there in 2n minus 2. But see the denominators, n factorial I am writing n into n minus 1 factorial. N into n minus 1 factorial. Now see the calculation. 2n minus 2 factorial, 2n minus 2 factorial cancel. N minus 1, n minus 1 cancel. Next here n cancel. Here 2, 2 cancel. What is the remaining? Remaining is here n. These are the remaining terms, 2n minus 1 and n. So the final answer is n by 2n minus 1. Students, which option correct? Tell me. Which option correct? Second option correct. N by 2n minus 1. There are 10 stations between A and B. A train is to stop at 3 of these stations. 3 of these stations. The probability that no 2 of these stations are consecutive. So here n of S is very easy. There are 10 stations. Out of 10 stations can be selected 3 stations. Those 3 stations are stopping stations. But what is the event here? E be the event that no 2 of this, no 2 of these stations are consecutive. That means in between two stopping stations required one non-stopping stations. Okay, so out of 10 stations, 3 stopping stations, subtract, remaining how many are there? 7 non-stopping stations. Okay, first arrange them 7 non-stopping stations. This is a 1, 2, 3, 4, 5, 6, 7. These are the 7 non-stopping stations. No need to arrange them non-stopping stations. No need to select them. But where it is condition C, no two of these stations are consecutive. Stopping station, on stopping stations, they are given condition. There are 3 stopping stations. No two of these stopping stations are consecutive. That meaning is in between at least one non-stopping station is required. Total 7 non-stopping stations are there. So we are selected like this. In between these, between means we can consider ends also. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 gaps. These 8 gaps can be filled with 3 stopping stations. In this case, the red color symbols, cross symbols, those are stopping stations. Those are stoppings. Observe here, there is no 3 consecutive stopping stations. Yes or no? In between, one non-stopping station is there. So cross mark is stopping station. Stop. Okay. Green color is, that is non-stop. Non-stop. Students observe clearly. How many chances are possible here? There are 8 chances. Out of 8 chances can be filled with 3. This is N of E. Now required probability. P of E, that is equal to N of E by N of S. 8C3 by 10C3. This is the answer. Students, which option correct? First option correct. I hope all of you understood now. Carefully. If the papers of 4 students, can be checked by any one of the 7 teachers, then the probability that all the 4 papers are checked by exactly 2 teachers. The probability that all the 4 papers are checked by exactly 2 teachers. Okay. Now, how to do that? First, find N of S. How many papers are there here? Paper 1, paper 2, paper 3, paper 4. That means 4 students are there. Each paper is a different student. Now, how many teachers are there? 7 teachers. 7 teachers having that to correct the first paper. How many chances? 7 chances. And remind next, second paper can correct. There are 7 chances because 7 teachers are there now. In third paper also there are 7 chances, and fourth paper also there are 7 chances. Okay, so N of S is 7 into 7 into 7 into 7. That is 7 power 4. What is n of e? See here, e be the event of that all the 4 papers are checked by exactly 2 teachers. Who that 2 people we want to select? N of e, exactly 2 teachers. How many teachers are there? There are 7 teachers. Out of 7 teachers can be select 2 teachers. I am going to select T1, T2. How many papers are there? P1, P2, P3, P4. Now here observe that each teacher having, so each paper having, there are 2 chances. Who will correct? Either T1 or T2. Chances are there or not? Okay, but all papers cannot be verified only one teacher. This case is not possible. All 4 papers cannot be verified only one teacher. See here, all the 4 papers are checked by exactly 2 teachers, not single teacher. This case is not possible. Yes or no? So by using onto function related concept, here n of a there are 4, n of b 2, n of b exactly 2 means number of onto functions, that is 2 power 4 minus 2. This is the formula. So out of 7 teachers can be selected 2 teachers. Those 2 teachers checked the 4 papers. The possible case is 2 power 4 minus 2. This is the answer. Now calculate this. 7C2 means 7 into 6 by 1 into 2. 2 power 4. 2 to the 4, 8, 16. 16 minus 2, that is 14. 2 sevens are 14. This is 7 square into 6. Now required probability P of E is equal to N of E by N of S. 7 square into 6 by 7 power 4. Students calculate this. 6 by 7 square. That is 6 by 49. This is the answer. Which option correct? First option correct.